We are going to start now the second lecture of chapter 4, class 12th mathematics, determinants. Now the first question we have is, without expanding, prove that this value of this determinant, this is equal to 0. So we start with this given determinant and we have performed the operation that row 1 approaches row 1 plus row 2. So when we are performing this operation, now look at the values the row 1 has. This is the row 1 we are talking about. It is x plus y, y plus z and z plus x. These are the terms in the row 1 and we have to add the values of the row 2. These are z, x and y. So if we add both these values, the matrix will become, it is x plus y plus z. This is the next term is also x plus y plus z, next term is also x plus y plus z. So these are the terms we are obtaining in the first row, and the next two rows we are talking about, they will remain same. Both these rows, they will remain same. Next step we have is, we have to take x plus y plus z common from row 1. So now we are having the matrix, the determinant in the form, it is x plus y plus z, then it is x plus y plus z, then it is x plus y plus z, and it is z, x, y, 1, 1 and 1. What we have done, we have taken this from this first row we are talking about, we have taken this element common. So when we take this element common, what we are left with is, it is x plus y plus z we have taken common. The determinant we are left with, in place of this, from the first row we have taken common, so it is 1, 1, 1, and rest we are left with is z, x, y, 1, 1 and 1. Now clearly what we have over here is, look at this first row, it is 1, 1 and 1. This last row, it is 1, 1 and 1. And we know that if the two rows, they are identical, then the determinant of that matrix comes out to be 0. So we have the determinant of this matrix is 0. The next question we have is, if omega is a complex cube root of unity, we have to prove that this determinant is equal to 0. So to solve this value, we are writing, this is the determinant given, 1 omega omega square, then it is omega omega square 1, then it is omega square 1 and omega. Now we are, look at these terms over here. If we look at, say we are talking about the first column, the elements we have, it is 1 omega and omega square. In the second column, the elements we have omega omega square and 1. In the third column, we have omega square 1 and omega. So if we add all these values, if we add, we are saying column 1 approaches column 1 plus column 2 plus column 3. Then the sum of all these values will be 1 plus omega square. Sum of all these will be 1 plus omega square. Sum of all these will be 1 plus omega square. And the value of 1 plus omega square, it is 0. So what we obtain is, we obtain this determinant over here, and all the values in this first row, they are 0, and as all these values, these are 0, so we obtain that the value of this determinant, it comes out to be equal to 0, and this is what we have to prove. Now next we have to prove that this determinant is equal to x into y. So if we look at the elements over here, we have 1, 1, 1. I'm talking about this first row, we have 1 over here. So with the help of this first one, we can make this term 0. We can make this one 0. So what we have to do is, we have to subtract, we are writing column 2 approaches column 2 minus column 1. Similarly, with the help of this one we are talking about, we can make this first term equal, this last term is equal to 0, and we have to perform the operation that column 3 approaches column 3 minus column 1. So if we perform this operation on this determinant, what we get is column 1 will remain as it is 1 1 1 over here. Next we have subtracted column 2 minus column 1, so this element will become 0, this will become x and this will become 0. Similarly we have subtracted C3, we have performed the operation C3 minus C1, so we will get it is 0 0 and y. So this is the determinant we have obtained. Now if we open this determinant along this first row, we are opening this determinant, expanding this determinant along the first row, clearly we have zeros over here, so this determinant will become 1 into, we are talking about this term over here, it is determinant of x 0 and 0 y. Next both these terms, these are 0, so we will get it is plus 0 plus 0. Now on opening this determinant, it is 2 cross 2 determinant, the answer we obtain it is x y, and this is what we have to prove. Next we have to prove is that this determinant is independent of theta. So if we look at these terms over here, we are expanding the values, expanding this determinant, we obtain that it is x determinant of minus x1 1 and x, then it is minus sine theta, the second term we are talking about, and we are left with is minus sine theta 1 cos theta and x, and last we are saying it is plus cos theta determinant of minus sine theta minus x cos theta and 1. On solving these values we obtain, solving this we will obtain it is x into minus x square minus 1, then it is minus sine theta into minus x sine theta minus cos theta plus cos theta into minus sine theta plus x cos theta. Next we obtain, when we multiply these terms, we will get it is minus x cube minus x plus x into sine square theta, then it is plus sine theta cos theta. Next we obtain it is minus sine theta cos theta plus x cos square theta. These two terms get cancelled, and look at these values over here, it is x sine square theta and x cos square theta. On combining this we will get it is x into sine square theta plus cos square theta, and the value of this term it comes out to be 1. So we are left with is minus x cube minus x plus x. Now this minus x plus x gets cancelled and we are left with is minus of x cube. So clearly what we will get is that this value we have, it is independent of theta, and this is what we have to prove. Now the next question we have is, we have to prove that this determinant is equal to 0. Now if we look at the elements over here, this is a, this is x, and this is a plus 2x. We have a plus 2x and x. So what we can see from this is that if we perform the operation that row 2 approaches row 2 minus row 1 plus 2 times row 3, we are talking about this value, row 1 plus 2 times row 3, this is row 1 element, this value will come out to be equal to this. Now if we subtract it from row 2, the answer we obtain that will be equal to 0. So we are saying row 1 plus 2 times row 3, this will give us the answer a plus 2x, b plus 2y and c plus 2z. When we subtract these values from the elements of the second row, this determinant will become, it is determinant a b c 0 0 0 and x y z. Now the entire row over here, this row we are talking about, it is equal to 0. So what we get is that the value of this determinant, it comes out to be 0. Next we have is, without expanding, we have to calculate this determinant. So if we again look at the terms over here, the first term we have over here, it is a plus b. This term we are talking about. The next we have it is 2a plus b, and next we have it is 3a plus b. So if we start subtracting this value 3a plus b from 2a minus b, we are talking about column 3 approaches column 3 minus column 2. So column 3 will become, this value will become, when we subtract these values, we are having 3a plus b and we are having 2a plus b. We are subtracting these values, we obtain, we are left with this a. So it is a. In the next term also we are left with this a, and from the last term also we are left with this a. So our determinant will become, it is a plus b, 2a plus b, this is 2a plus b, 3a plus b, this is 4a plus b, this is 5a plus b, and these last values we are getting, it is a, and a. Now if we look at these two terms over here, it is a plus b and 2a plus b. Now the operation we are performing over here, it is row 2, column 2. It is not row 2 we are talking about, we are talking about it is column 2 approaches column 2 minus column 1. Now column 1 will remain as it is a plus b, 2a plus b and 4a plus b. Now we are subtracting the terms of this from this, so we are left with this a and a. Last column it is a and a. Now if we look at both these columns, it is a and a, this is a and a, both these are identical. So what we obtain is, the final answer we obtain, that is equal to 0, and this is what we have to prove. Next we have to evaluate the value of this determinant. So the values over here, the first thing you can do is you can manually open this, expand this determinant. You will get it is 265, then determinant of 225, 198, 198, 181. Similarly the next term, but we can see from here that if we open this determinant, the answer you will get it is 225 into 181 minus 198 square. You will get some answer, and then you have to multiply it with this. So the terms over here, if you have to solve this, the multiplication over here, it will be very lengthy process. So in place of doing this, what we have done to simplify these values, we have performed these operations that column 1 approaches column 1 minus column 3 and column 2 approaches column 2 minus column 3. So column 3 over here, we are talking about, this is column 3, it is as it is, and we have subtracted the values over here. It is 265 minus 219, it is 46, 240 minus 98, we have it is 42, and the last value we have it is 219 minus 181, it is 38. Now similarly we can obtain the values corresponding to this second column. We have subtracted, performed the operation, it is column 2 approaches column 2 minus column 3. Now further to simplify these values, we have performed the operation. Look at this column over here, it is 46, 42 and 38, and this is 21, 27 and 17. So if we write 46 minus 2 times 21, the answer we will obtain, it is 46 minus 42, that is equal to 4. So our value will become small. So we have, in the next step, we have performed the operations. It is column 1 approaches column 1 minus 2 times column 2, and column 3 approaches column 3 minus 10 times column 2. So these values are reduced over here. This is 4 minus 12 and 4, and this value is reduced to 9 minus 72 and 11. Next, if we look at these values over here, it is 4 over here, this is 4 over here. So to reduce these values, we have performed the operation, we have subtracted these two rows, we have performed the operation that row 1 approaches row 1 minus row 3 to make this 4 equal to 0. Then we have minus 12 over here. So to make this term 0, we have performed the operation that row 2 approaches row 2 minus plus 3 times row 3. So what will happen over here? Row 2 element it is minus 12 and we are saying plus 3 into 4. The answer we obtain that will be equal to 0 corresponding to this minus 12. So our determinant will come in this form, that it is determinant of terms we have, it is 0, 4, minus 2, 0, 78, minus 39, 4, 17 and 11. Now if we open this determinant, we obtain, we have taken from this first row we are talking about, we have taken 2 common, and from the second row, this second row we are saying 10, 78 and minus 39, we have taken 39 common. So what we have obtained from this is, this first row we are talking about, it is 0, 2 and minus 1. This second row will become 0, 2 and minus 1. Both these rows, these are identical, and if both these rows are identical, we obtain that the determinant value it is equal to 0. Next is, without expanding, we have to prove that this determinant is equal to 0. So the first step we have done over here, the term we have over here, it is cos of alpha minus delta. We have applied the formula and we obtain it is cos alpha cos delta minus sin alpha sin delta. For the second term, it is cos of beta plus delta, and for the third term we have cos of gamma plus delta. Now look at this third column over here. What we can see is this term over here, it is cos delta and cos delta, and this term over here it is sin delta and sin delta. Now look at these values. This is cos alpha and this is sin alpha. Again this is cos beta, this is cos gamma. Similarly we have, this is sin beta and this value we are saying it is sin of gamma. So the operation we can perform is, we are saying that from these terms we can form this, because alpha beta gamma these are constant. So we are writing that column 3 approaches column 3 plus, we are writing it is sin delta times C1. We are talking about, this is column 1, we are multiplying it with sin delta, this value, and it is minus C2 into column 2, we are multiplying it with cos of delta. So when we perform this operation, we can see that this last column over here, we are talking about this column, this will become 0. So on expanding, we obtain that value of the determinant, it comes out to be 0, and this is what we have to prove. Next we have to prove that this determinant is equal to a cube. So if we look at this first column over here, it is a, 2a and 3a. So the operation we can perform with the help of this a, we can make both these terms 0. So we are writing that row 2, I am not talking about the column operations over here, we are talking about the row 2, it approaches row 2 minus 2 times row 1, and row 3 approaches, it is 3a over here, this is a over here, so it is row 3 minus 3 times row 1. So when we solve these values, when we perform these operations, this term we have over here, it is a plus b plus c. The operation is not performed on the row 1, and the remaining two rows, they will be, when we subtract these values, these two values will become 0, and what we are left with over here, it is a, 2a plus b, and the next term you will get, it is 3a and 7a plus 3b. Now if we open this determinant along the first column, we are not opening it along the first row, we are opening it along the first column. the answer we obtain, it is a times determinant of a 2a plus b, then it is 3a 7a plus 3b. Now this is a and this is 3a, so we are performing the operation that row 2 approaches row 2 minus 3 times row 1. So this will be equal to a times this first row, it is same, it is 2a plus b. Second row, this element will become 0 and the second element will become, we are writing it is row 2 means 7a plus 3b minus 6a minus 3b. So we are left with over here it is a. So when you open this determinant, the answer you will obtain, it is a into a square, that is equal to a cube, and this is what we have to prove. Next we have is to prove that this determinant is equal to 4 times a square, b square and c square. So we are saying if we look at the values over here, we can take from this column 1, we can take a common, from the column 2 we can take b common, and from column 3 we can take c common. So what we obtain, it is a b c and determinant of minus a, then b, then c, a common, then b common, it is a minus b and c, and from the last one we are saying it is c common. So we are left with is a, b and minus c. Now look at these values over here. We are saying from this first row we can take a common, this abc is already common. Now from the first row we are taking a common, we are left with is minus 1, 1 and 1. From the second row we are taking b common, it is 1, minus 1 and 1. From the third row we are taking c common, it is 1, 1 and minus 1. Now the next step we are going to do is, with the help of this minus 1 we are going to make both these term equal to 0. That is, we are performing the operation that row, it is row 2 approaches row 2 plus row 1 and row 3 approaches row 3 plus row 1. So this becomes a b c whole square. Determinant of row 1 is as it is minus 1, 1 and 1. We have added these values, these two will become 0, this value will be 0, this is 2, this is 2 and this is 0. So if we open this determinant, we simplify this determinant along this first column, we obtain the answer in the form, this will be simplified in the form, it is a b c whole square, and then we are having minus 1 into determinant of 0 2 2 0, and determinant of this value, it comes out to be minus 4. So the final answer we obtain, it is minus 4 into minus 1, it is 4 a square b square c square, and this is what we have to prove. Now in this question we have to prove that this determinant is equal to 2 times a cube, b cube, c cube. So if we look at the terms over here, from this first column if we look at, we can take a square common. From this second column we can take b square common, and from this third column we can take c square common. So we are writing it is a square b square c square, determinant of 0 b c, then it is a 0 c, and then it is a b 0. Now look at this first row over here, we can take a common from this, from second we can take b common, and from third row we can take c common. So this value we are writing it is a square b square c square is already there. From the first row we have taken a common from b, and from the third we have taken c common. We are left with 0 1 1 1 0 1 and 1 1 0. Next, if we look at these two rows over here, we are saying from with the help of this 1 we are going to make this term 0. So we are writing it is row 3 approaches row 3 minus row 1 row 2. not row 1, it is row 2. So we get it is a cube, b cube, c cube, and determinant it is 0, 1, 1. Row 1 is not changed, row 2 is not changed, and row 3 will become 0, 1 and minus 1. Now if we open this determinant along, say, this first column we are saying, so what we are left with is, it is a cube, we are left with is a cube, b cube, c cube. If we are opening the determinant along this, it is minus 1 over here, and we are left with this determinant of 1, 1, 1 and minus 1, and this value comes out to be minus 1, minus 1, minus 1, minus 1, so it is minus 2. So what we are obtaining, it is minus 2 over here, minus 1 over here. So the final answer we obtain, it is 2 times a cube, b cube, c cube, and this is what we have to prove. Next we have to solve this determinant. So look at these values over here, it is x, x, 4x and 8x, this is x, 2x and 3x over here. So one thing we can do is, one of the procedures to solve this is, we separate this determinant in two parts. Along the first column we get it is x, x and x, it is 5x and 10x, 4x and 8x, 2x and 3x, plus determinant of y, 4y, 8y, this is x, 4x, 8x and x, 2x and 3x. Now if we look at these two columns, they are proportional to each other, it is y is to x, it is y is to x, this is y is to x. So it means the value of the determinant for this part, that will be equal to 0, because both these columns, these are proportional to each other. Now from this second part, if we take x common from all these three rows or columns, we are obtaining it is x common from first, second and third, we are left with is 1, 1, 1, 5, 4, 2 and 10, 8, 3. Now to solve this determinant, with the help of this 1, we can make both these terms 0. So we are performing the operation that column 2 approaches column 2 minus column 1, column 3 approaches column 3 minus column 1. So we get it is x cube, determinant of 1, 5, 10. These two values will become 0. We are left with this 1. It is minus 1 over here, and the next values we will have, it is minus 3, then it is minus 2 and minus 7. So if we open this determinant along the first row, we will obtain the answer in the form, it is equal to x cube, determinant of minus 1, minus 3, minus 2 and minus 7, that is equal to x cube into 7 minus 6, that is equal to x cube. So we obtain that the value of determinant in this case, it is x cube. Next is prove that the determinant, this value, that is equal to a minus b, b minus c, c minus a. So if we look at these terms, this is 1 over here. So with the help of this one, we can make both these terms equal to 0. So we are performing the operation that row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So what we obtain from this, it is 1a square. These two values, these will become 0. Then we have b minus a, b square minus a square. This value, it is c minus a, this is c square minus a square. Now if we open this determinant along this first column, we obtain this is equal to 1 into determinant of b minus a, b minus a into b plus a, and then it is c minus a, c minus a into c plus a. Now from this first row, we are writing b minus a common. From this second row, we are writing c minus a common, and we are left with is 1 b plus a and 1 c plus a. Now either you can directly open this determinant, you will get the answer, it is b minus a into c minus a. When you multiply these terms, you will get c plus a minus b minus a. So what we get, the answer is a minus b into, from this gets cancelled, we have minus sign, we have adjusted over here, you will get it is b minus c, and last we are getting it is c minus a, and this is what we have to prove. In this question we have to prove that this determinant is equal to this value. So again, with the help of this 1, we can make both these terms equal to 0. So we are performing the operation that column 2 approaches column 2 minus column 1, column 3 approaches column 3 minus column 1. So the determinant over here we will have, it is 1 a cube, it is 0 0 over here, this is b minus a, b cube minus a cube, this is c minus a, this is c cube minus a cube. Now from if we open this determinant, say along this first row, the answer we get, it is determinant of b minus a, c minus a, b cube minus a cube, c cube minus a cube. Now either you cross multiply these terms, so you open the determinant, or what operation we can perform from these two terms, we are writing b minus a common, we are left with is 1, it is b cube minus a cube, the formula we will have, it is b square plus ba plus a square. Next we are taking c minus a common, we are left with is 1 c square plus ac plus a square. Now on solving this determinant, the answer we obtain, it is b minus a into c minus a into c square plus ac plus a square minus b square minus ba minus a square gets cancelled. Now what we are left with is this value, we are saying it is b minus a into c minus a. From these two terms we are writing it is c minus b into c plus b. From these two terms we can write a common, and we are left with is c minus b. So from all these terms we can see, we can write c minus b common. So we are left with this c plus b plus a. We are left with c plus b plus a into c plus b plus a. This is c minus b, and this is what we have to prove. We are talking about the terms over here. It is b minus a, then it is c minus a, and then it is b minus c, and then it is a plus b plus c over here, and this is what we have to prove. Next question, we have to prove that this determinant is equal to this value. So if we look at the determinant over here, this term we have beta plus gamma, this is gamma plus alpha, and this is alpha plus beta. This term over here, it is alpha. So if we add this alpha over here, the term will become alpha plus beta plus gamma. If we add this term beta over here, it will become alpha plus beta plus gamma. If we add this gamma over here, we will get alpha plus beta plus gamma. So we are performing the operation that row 3 approaches row 3 plus row 1. So our last row will become this row we are talking about, it is alpha plus beta plus gamma, alpha plus beta plus gamma, alpha plus beta plus gamma. We have taken alpha plus beta plus gamma common from the last row. So these terms will become 1, 1 and 1. Next step we are going to do is, with the help of this 1, we are going to make both these terms 0. So we are performing the operation that column 2 approaches column 2 minus column 3, column 1 approaches column 1 minus column 3. So what we will get from this is alpha plus beta plus gamma is there. Then we are talking about value of determinant. It is 1, 0 and 0. This value it is gamma square and this is gamma, and we are subtracting the other values over here. So we will get it is alpha minus gamma, beta minus gamma, alpha square minus gamma square, beta square minus gamma square. So from this what we will obtain, look at these two terms over here. We are talking about these two terms. We can write alpha minus gamma common. So we are having alpha plus beta plus gamma into alpha minus gamma. From the next two terms, it is beta minus gamma, beta square minus gamma square. We can write beta minus gamma common. So what we are left with is, it is 1, 1 gamma. It is alpha plus gamma, beta plus gamma and gamma square. And these values we have, it is 0, 0 and 1. Now if we open this determinant along this row, the answer we obtain, the value of this determinant we are talking about, this will be equal to determinant 1, 1 alpha minus gamma, beta plus gamma. This is equal to beta plus gamma minus alpha minus gamma. So these two values gets cancelled and we are left with is beta minus alpha. Final answer we are obtaining, it is of the form, we are saying it is alpha plus beta plus gamma, then we have alpha minus gamma, then we have beta minus gamma, and last term we are getting it is beta minus alpha. So what you can do to bring it into this form, in place of this we are writing it is alpha minus beta, minus sign is there, and that minus sign it is adjusted over here and we are writing it is gamma minus alpha, and we obtain the answer in this form. So these are the calculations shown over here. Next is using properties of the determinant, we have to show that this value is equal to a square into a plus x plus y plus z. Now if we perform the operation, look at this operation over here, it is column 1 approaches column 1 plus column 2 plus column 3. We will get this is a plus x, y and z. Next we will obtain it is a plus x plus y plus z, and third also we will obtain it is a plus x plus y plus z. So we can write this term a plus x plus y plus z common from these three, and our first column will become, this values we are saying it is 1, 1 and 1. These are the values we are saying. Now in this determinant, with the help of this first one, we can make both these terms equal to 0, and to do this we have performed the operation that row 2 approaches row 2 minus row 1 and row 3 approaches row 3 minus row 1. So row 1 it is 1 y and z, it is as it is. Next we are saying this term is 1 over here, so we are subtracting over here, we get it is 0 and 0. Next when we solve this, it is y and this is a plus y, so we are left with a and 0, this is 0 and a. So if we open this determinant along this first column, we are talking about 1 0 0, the answer we obtain it is in this form. So the final answer we get it is a square a plus x plus y plus z. We have to prove that this determinant 1x x square 1x and x square 1, that is equal to this value. So if we look at these terms over here, it is 1 x and x square, next it is 1 x and x square, and the third value again we have it is 1 x and x square. So it means if we add these three columns, we are writing it is column 1 approaches, we are talking about column 1 approaches column 1 plus column 2 plus column 3 then the elements of this first column, they will come in the form 1 plus x square. All these values, they come in this form. So we are obtaining the determinant in this form. Now if we take this term common, we are talking about this 1 plus x square. It is present in all these three rows in this first column. So we are taking this term common over here. So what we are left with is, it is 1 1 and 1, and rest all the terms they are same. Now the next step we have to do is, we have to, with the help of this one, we are making this one 0 and we are making this one 0. So we have performed the operation that row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So these two terms, these will become equal to 0, and when you subtract these values come in this form. Now if we look at these rows carefully, we are talking about say this second row, we have the term 1 minus x over here. In this third row, we have the term 1 minus x. We are talking about these terms. It is 1 minus x over here, x minus 1, 1 minus x, 1 minus x. So if we write 1 minus x square common, either we have to take these terms common from these rows. We have taken these terms common. So we obtain the remaining determinant, this column, it is as it is. Next we have taken 1 minus x common, so it is 1, this is x, this is minus x, and this is 1 plus x. Now if we open this determinant along the first column, we obtain this is 1, and we are left with this part of the determinant. And on expanding this, on solving this value, you can obtain the final answer in the form 1 minus x cube raised to the power 2. Now the next we have to solve this determinant, and we have to prove that its value is equal to x plus y plus z whole cube. So if we look at this determinant, we can see the values we have over here. We are talking about this is 2y, and this is 2z, and the value we have over here, it is x minus y minus z. So if we add all these three values, we will obtain x plus y plus z. Similarly, if we add the next three values, we will obtain it is x plus y plus z. If we add next three values, we will obtain x plus y plus z. So the operation we are performing over here, it is row 3 approaches row 1 plus row 2 plus row 3. So our last elements of last row, they are changing, and we have obtained over here, it is x plus y plus z as element in the last row. So we have taken this element common, this element x plus y plus z we have taken common from this last row, and we obtain over here all these three terms, they will become 1 1 and 1. Now with the help of this one, this we are making this one 0, and we are going to make this one 0. So what operation we have to perform? We have to perform the operation that column 1, we are changing the column 1 approaches column 1 minus column 3. We are talking about, we have to make this term 0 with the help of this 1. Similarly, we have to make this term 0 with the help of this one. So we are applying the operation that column 2 approaches column 2 minus column 3. So these two terms, they will become 0, and these values, these are changed accordingly. These values, these are changed accordingly. You can see how these values are changing. If suppose I am talking about this value, it is 2y and 2y, so 2y minus 2y we obtain it is 0. Then we are writing y minus z minus x, and this is 2y, so we are obtaining this term. Similarly, we are getting these answers. Now the next step we have to do is, we are talking about this 1 is there, this value 1 is there, and we are opening the determinant along the row 3. We are talking about, this is our row 3, we have opened the determinant about this row. We obtain this is 1 and these are the terms 0, x plus y plus z, minus of x plus y plus z and x plus y plus z, and if we open this determinant we will obtain the final answer in the form x plus y plus z whole cube, and this is what we have to prove. In this question we look at this determinant over here. Now this element over here, it is 3a, this is minus of a plus b and this is minus of a plus c. So if we add all these values, the answer we obtain, that will be a plus b plus c. Similarly, if we look at the elements of the second row, it is a minus b, this is 3b and this is c minus b. Again, if we add these values, the answer we will obtain, it is a plus b plus c, and similar is the case with the third row. We will get the answer as a plus b plus c. So the operation we have applied over here, it is C1 approaches C1 plus C2 plus C3. So this is our first column. All these elements, we have added all these values and we obtain that all these values, they come out to be a plus b plus c. Now if we take this a plus b plus c common from this first column, we are writing it is a plus b plus c. We have taken this term common from the first column. We are left with this 1, 1 and 1. Next step we have to do is, with the help of this first one, we are going to make both these terms equal to 0. So we have performed the operation that row 2 approaches row 2 minus row 1, row 3 approaches row 3 minus row 1. So these terms, they will become 0 and these terms will be changed accordingly. Now next step we have to do is, we have to open the determinant along this first column. We are opening the determinant along the first column. So what we are left with is, this term is 1 over here, we have 1 over here, and we are left with this part of the determinant. We are talking about this part when we open it along with the first column. Now by cross multiplying these terms, or by expanding this 2 cross 2 determinant, we obtain the final answer in this form, that it is 3 times a plus b plus c into ab plus bc plus c a. Next is b plus, this determinant is given, it is b plus c, then c plus a, then a plus b, these terms are there. So we have to prove that this is equal to this value. So again, if we look at these values carefully, we can see that if we add these rows or column, you can perform the operation in any of these ways. So suppose we are performing the operation that we have added the, this is first row, this is b plus c, this is c plus a, and this is a plus b. We are talking about this first column. If we add all these values, the answer we will obtain, it is 2 times a plus b plus c. Similarly, if you add the elements of this second column, you will get the same answer. If you add the elements of this third column, you will get this answer. So it means if we perform the operation that row 1 approaches row 1 plus row 2 plus row 3, this first column we are talking about, it will be in this form, that it is 2 times a plus b plus c. This is our first column. Now we are writing this common, 2 times a plus b plus c, we have written common over here. So these terms, they will be changed to, this term will be 1, this is 1, this is 1, because this term we have taken common from the first row. Now the next step we have is, with the help of this one, we are going to make both these 0. With the help of this one, we are going to make both these zeros. It means we are going to apply the operation that column 2 approaches column 2 minus column 1, and column 3 approaches column 3 minus column 1. So these two terms we have made 0, and corresponding to this, these values are also changed by this operation we are talking about. By this operation, these values are also changed. Now we expand this determinant along the first row. When we expand it along the first row, the terms we are left with is this. We are talking about the 2 cross 2 determinant. Now we are left with this in the form b minus c, b minus a, c minus a, and c minus b. So to expand this determinant, we have used the formula for the expansion of 2 cross 2 determinant, and we obtain the final answer in the form this 2a plus b plus c. This we have already obtained, and this remaining portion we have obtained by solving this, by expanding this determinant. Next is prove that the value of this determinant is equal to a plus b plus c whole cube. Again, if we look at the elements over here, we can see that if we add the elements of this first column, we will have a minus b minus c plus 2b plus 2c. So on adding this, we will get a plus b plus c. Similarly for the second column, similarly for the third column. So the operation we are going to perform over here, it is row 1 approaches row 1 plus row 2 plus row 3. So all the elements in the row 1, they will be in the form a plus b plus c. Now if we take this term common, we are talking about we have taken a plus b plus c common. These first elements we have over here, it is 1, 1 and 1. Now the next step we have to do is, with the help of this first one, we are going to make this 0. With the help of this first one, we are going to make this 0. So the operation we have to perform is that column 2 approaches column 2 minus column 1, and column 3 approaches column 3 minus column 1. So our given matrix, it will reduce into this form, that it is 1, 0, 0, and these values are changed accordingly. These are changed accordingly. Now if we open this determinant, we will get this is 1 over here. We will get the answers in this form. This portion of the determinant we have obtained, 2 cross 2 determinant we are talking about. And on expanding this determinant, we have the terms over here. It is minus of a plus b plus c, minus of a plus b plus c. So the final answer we are getting, this is a plus b plus c is already there. On multiplication of these two terms, we will get a plus b plus c. So the final answer we are getting, it is a plus b plus c whole cube. Next is this determinant, we have to prove that it is equal to 2 times a plus b plus c whole cube. So if we add these column wise, we are saying this is a plus b plus 2c, and this element, these are a and b. So if we perform the operation that column 1 approaches column 1 plus column 2 plus column 3, the determinant will become, it is 2a plus 2b plus 2c. This is 2a plus 2b plus 2c, and then it is 2a plus 2b plus 2c, and we have these values, they will be there as it is. Now if we take 2 times a plus b plus c common, 2 times a plus b plus c common, we are talking about these values. We have taken these values common. So we are left with the determinant, it is 1, 1, 1, and the terms we have over here, it is a, b, this is b plus c plus 2a and b, and this is a, this is c plus a plus 2b. Now next step we have to do is, with the help of this one, we have to make both these terms 0. So we are performing the operation that row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So the final answer we obtain, it is 2 times a plus b plus c, determinant of 1 a b. Now these values, these will become 0, these two values will become 0, and on solving this, we will obtain the value as b plus c plus a, and this value as a plus b plus c. Now if we open this determinant along this first column, if we open the determinant along this first column, we obtain the final answer in the form, it is 2 times a plus b plus c. Then we have multiplication of these two, so the power we obtain over here, it is 3, and this is what we have to prove. Next we are given this determinant. So to solve this determinant, we are going to perform the operation in the form. It is column 1 approaches column 1 minus column 3. So column 1 means we are saying A and C are there. So we are getting A minus C, A square minus C square, and BC minus AB. And then we are going to perform C2 approaches C2 minus C3. So C2 means we are talking about B, B square and CA. So these are the three terms we are obtaining over here. Now if we look at this term, it is basically B into C minus A. If we look at this term, this is A into C minus B. So from the first column, if we are looking at this first column, we can take A minus C common. From the second column, we can take B minus C common. So we are left with these terms over here. We are left with these terms over here. Now the next step we have to do is, with the help of this one, we have to make both these terms 0. So we have performed the operation. We are saying to make this one 0, we are performing the operation that column 2 approaches column 2 minus column 1. To make this C 0, we are having 1 over here and C over here. So what we are going to do, we are saying column 3 approaches column 3 minus, what do we have to multiply over here? It is C times column 1, where C is any constant. So if we apply these operations, we will obtain that our first row we are talking about, it is 1 over here. This term will become 0, this term will become 0, and these values, these are changed according to these operations. These values, these are changed according to these operations. Now if we open this determinant along this first row, what we are left with is 1 into B minus A, B minus A, minus CA, A plus C into B. Now we can take B minus A common. So we are left with this 1, 1 minus CA, A plus C into B. When we open this determinant, you will get it is A, B plus B, C plus C, A. These terms, these are cross multiplied over here. So we get it is A, B plus B, C plus C, A. And this is what we have to prove, that it is A minus B into B minus C into C minus A into AB plus BC plus C, A. Next is we have to prove that this determinant is equal to this value. So again, if we look at this first column over here, we are talking about the elements of the first row, we are considering the first column over here. If we add these values, the answer we obtain, it is A plus B plus C. If we add the elements of this value, these values, this first second row, we will get it is A minus B plus B minus C plus C minus A. The answer we will obtain, it is 0. And if we add the values of this third row, we will get the answer as 2 times A plus B plus C. So we have performed the operation over here. It is C1 approaches C1 plus C2 plus C3. So what we have obtained, it is A plus B plus C, then it is 0, and last we are obtaining it is 2 times A plus B plus C. Now from this first column, we can take A plus B plus C common. So what we obtain from this we are getting 1, next term we are getting 0, and last term we are getting it is 2 over here. Now it is already 0 at this point. With the help of this 1, we want to make this 0. So what we have to do, we are saying row 3 approaches row 3 minus 2 times row 1. We are talking about row 3 element, it is 2. Row 1 element, that will be 2 into 2. So the answer we obtain, that will be equal to 0. So we have performed the operation over here, that row 3 approaches row 3 minus 2 times row 1. So both these elements, they will become equal to 0, and correspondingly this last row, it has changed. Now we open this determinant along the first column. So the terms we are left with is these terms. We are left with this part of the determinant. We are talking about this part of the determinant we are left with. So on expanding these values, we will obtain the final answer in the form this. We are saying if we expand this determinant, we will obtain the final answer in the form that it is a cube plus b cube plus c cube minus 3abc. Next is if a, b, c are positive and unequal, we have to show that this determinant is negative. So again, if we look at the elements of this determinant, we have the sum of all these three in the first row we are talking about, it is a plus b plus c, similarly sum of second and similarly sum of third. So the operation we have performed over here, it is column 1 approaches column 1 plus column 2 plus column 3. So all these elements we get, it is a plus b plus c, a plus b plus c and a plus b plus c. Now if we look at this first column over here and we are writing a plus b plus c common, we are left with this determinant. Next is with the help of this 1 we have to make both these terms 0. So we have performed the operation that row 2 approaches row 2 minus row 1, row 3 approaches row 3 minus row 1. So what we obtain from this is that this value becomes 0 and this value becomes 0, and correspondingly the values of these elements, these are changed. Now if we open this determinant, the answer we are getting, it is a plus b plus c into c minus b, b minus c minus a minus b into a minus c, and if we adjust these values we will get the answer in this particular form. Now it is being given that a, b, c are positive. It means this portion we are talking about, this first part, this is always positive. This part we are saying this is always positive. Now we are looking at or interested in this second part. So if we multiply the second part with the 2 and divide it with the 2, we are talking about this value, we are writing it is minus sign common, we are left with this a square plus b square plus a c square. We have divided it with 2, we are multiplying it with 2. These all terms minus sign we have taken common, so it is minus 2ab minus 2bc minus 2ca, and we can see this is what we can write over here, it is a square plus b square minus 2ab. We are saying this is a square b square minus 2ab. We have a square is 2 times over here, so we can write it is a square plus c square minus 2ac. Now we are left with this 1b and 1c, so it is b square plus c square minus 2bc. Now these are the formulas for a minus b whole square. Second is the formula for b minus c whole square, this term, and this third one is c minus a whole square. And we can see that these values we are talking about, these values, these are whole squares, and all these values are added. So it means these terms are also positive, this term is also positive, we have negative sign over here. So what we are saying that this final answer we have, it is negative, and this is what we have to prove, that the value of the determinant is always negative.